Okey, sekali lagi cikgu ucapkan selamat datang dan terima kasih. Selamat bercuti semua. Jadi petang ini marilah sama-sama kita manfaatkan waktu cuti yang ada untuk kita sambil-sambil kita ulang kaji satu lagi tajuk pada hari ini, iaitu tajuk fizik untuk tingkatan 5, iaitu 2.3 tekanan gas ataupun gas pressure dalam DLP. Jadi kelas pada hari ini akan disampaikan oleh Mr. P dari Kolej Tingkatan 6 Tun Fatimah Melaka. Kini Mr. P berada di puncak bukit mana tu, nanti Mr. P akan show kongsi detailnya. Dan bersama kita selain pada Mr. P, iaitu cikgu sendiri, Cikgu Hasbita dari SMK Bagan Jaya selaku moderator anda pada petang ini. Dan kita juga turut ditemani oleh Cikgu Yani dari SMK Bandar Bintulu Sarawak. Okey, jadi dengan tidak membuang masa lagi, sebelum saya serahkan kepada Mr. P, jom kita mulakan kelas kita pada petang ini dengan Ummul Kitab Al-Fatihah. Yang bukan beragama Islam bolehlah bertafakur mengikut kepercayaan masing-masing. Al-Fatihah. Amin, amin ya rabbal alamin. Jadi jom ajak lagi rakan-rakan yang lain sama-sama kita ulang kaji pada petang ini. Sebelum cikgu serahkan kepada Mr. P, cikgu kongsikan dahulu dua kod yang pertama. Okey, dengarkan baik-baik kodnya, iaitu A2. Okey, dua kod yang pertama A2. Okey, silakan Mr. P.
Okay, so terima kasih moderator hari ini Cikgu Asita. Okay, so sekarang Cikgu showkan slide ini merupakan kelas tuition percuma fizik SPM, promosikan sedikit. So kelas untuk tingkatan 4 seperti biasa diadakan pada setiap Jumaat pukul 9:30 malam. So sekarang kita sudah sampai subtopik 26 daya, So kalau kamu belum lagi, mengikuti live Cikgu Rosmawati, so bolehlah visit channel Cikgu Ros, So kelas untuk tingkatan 5 adalah seperti hari ini, setiap Ahad pukul 2 petang. So ini merupakan panitia fizik SPM Akademi Universiti Malaysia. Hari ini bersama saya, di konti adalah Cikgu Hasita dan juga Cikgu Yani. Terima kasih cikgu-cikgu bercuti. Masih bersama Cikgu P dan bersama murid, untuk mengadakan kelas tuition AYU percuma ini. So saya Cikgu P, dari Kolej Tingkatan 6 Tun Fatimah Melaka. So seperti Cikgu Hasita sebut, hari ini kita semua bercuti. Sebenarnya Cikgu P berada di Cameron Highland, So walaupun Cikgu bercuti, so saya rasa cikgu-cikgu AYU akan kekal memberi komitmen yang tinggi, mengajar, memberi panduan kepada para pelajar. So subtopic for today will be 2.3 gas pressure. This will be the continued subtitle for our chapter 2 pressure. So in today's subtopic 2.3, we will have two learning standard. So for learning standard 1 is to determine gas pressure using a manometer. And the second learning standard for this subtopic is solve problem involving gas pressure in daily life. So before we go to our first subtopic, let us recall some of the knowledge, you actually already learned at Form 2, Chapter 8, Section 8.2 is regarding the definition of the gas pressure and also the factor affecting the gas pressure. Actually, this topic also quite related to the topic Chapter 4, Physics at Form 4, Chapter 4, which is regarding the gas law. So here, firstly, you can look at the GIF, you can see the movement of the dot, red color and the blue color. So they are actually gas particles. From the GIF, you can see very clear that the gas particles move randomly and collide with the wall of the container. So the wall of the container will be here. And cause the force to act on the wall. Okay, so that means when the particles hit or collide to the wall of the container, there will be a force act on the wall. Therefore, the gas pressure is the force per unit area exerted by the gas molecule as they collide with the wall of the container. So actually, this is also we already discussed the formula. P is equal to F over A at section 2.1. Okay, so that means that the gas pressure is also applying the same formula where is the force per unit area. Okay, but here we emphasizing for the gas molecule colliding on the wall or container. Okay, so we recall back what is the factor. What is the factors that affect the gas pressure? So first, temperature. Second is the mass of the gas particles. And then the third will be the volume of the container. Okay, so this is a three factor which affect the gas pressure. Okay, so for the first factor, which is the temperature. So you can look at the figure here. Okay, so there are two figures here where the particles at the room temperature and also under the hot condition. Okay, so when gas is heated, so you can look at the bottom figure. Okay, the temperature of the gas in the container increases. Okay, so for example, initially the room temperature is about 25 degrees Celsius, but at Cameron Highlands will be about 70 degrees Celsius to maybe 19 now. Okay, so when you heat it, so the gas particles in the air will be collide to the container more frequently. Okay, so the temperature will be increased. So because we know that the temperature of the particles, the temperature of the air is the average kinetic energy of the particles. Okay, so here when gas heated, the temperature of the gas in the container increases. And then gas particles move faster and collide with the wall or container and cause the force to act on the wall. So you can see at the bottom figure, the particles is move more faster so that the force applied will be increased. So gas pressure is the force per unit area. So this is the definition for the gas pressure. Okay, so when the force increase, the pressure, gas pressure will also increase. Okay, so therefore as force increases, gas pressure increases. Okay, so now we go to our second factors, which is the mass of the gas particles. Okay, so from here you can see at the first figure, okay, so the numbers of particle is less. And then the particle is add on to the container. Okay, you can look at the figure here. The gas cylinder, okay, supply more air to the container and cause the numbers of particle, or here mass of particle increases. Okay, so when more gas added, there are more collection of the gas particles to the wall of the container. Okay, so that means that the figure 2, the particles will collide. Okay, the frequency of collision between the gas particles to the wall or container will be increased, so that the force added on the wall or container will also increase. Okay, so greater collection, to the wall or container will produce greater force. So and then the gas pressure, which is the formula F over A, when the force increases, therefore the pressure, the gas pressure will also increases. Okay. Okay, so the last factor affecting the gas pressure here in our discussion will be the volume of the container. Okay, so look at the GIF again. Okay, so for the first figure, you can see the volume, okay, is smaller. while the figure 2, the volume of the container, okay, is bigger lah, okay. Okay, so when the volume of the container decreases, okay, like figure 1, there are more collection of the gas particles to the wall or container. So you can look at the GIF here. So the particles is collect more frequently to the wall or container compared to the second figure here. Okay, so that you can see the greater force. Okay, greater force will be applied on the wall or container. Okay, so greater collection to the wall or container will produce greater force. So, and then we discuss about the gas pressure, okay, which is the force per unit area. Okay, so as the F increases, okay, force increases, so that means the gas pressure will also increase. Okay, okay, so this is the recall question actually regarding the chapter 4 physics form 4 and also the chapter 2 of the science when you learn at PD3 form 2. Okay, so this is also one of the question I take from the SPN question 2018. Okay, is regarding the factor affecting the gas pressure. Okay, so let us go through the question together. So the gas pressure in a container is caused by the correction of the gas molecule with the wall or container. Which of the following option will cause the pressure increase? Okay, as per discussion just now, there are 3 factors affecting the gas pressure, which is the temperature, mass of the gas particles, and the volume. So here, when we discuss about the increasing of the gas pressure, so that means we require higher temperature, more mass of the gas particles, and smaller volume of the container. So for the first A, increase the average velocity. So the velocity of the gas is not related, is or not affected the gas pressure. So that means this is not the answer. So for B, okay, for B, increase the volume of the container. So we should decrease the volume of container to increase the gas pressure. Okay, so that means this is also not the answer. And then for the C, decrease the mass of container. Okay, so according to our discussion, this will be the answer, right? Okay, so we read again for the D. So is it, where is the part is actually wrong already for D? So decrease the temperature of the gas. Okay, so that means this decrease is wrong already. We need to increase the temperature. Okay, so the answer will be C. Okay. Okay, so now let us go to our first learning standard of subtopic today. Okay, so the first learning standard here is to determine the gas pressure using the manometer. Okay. Okay, so what is a manometer? So a manometer consists of U-shaped glass tube filled with a liquid. Okay, so you can see at the figure here. So we have a U-shaped glass tube. Okay, and here the liquid we're using will be mercury. Okay, so water or mercury are used in a manometer to measure gas pressure. Okay, is to measure the gas pressure. So that means besides the mercury, we can actually using water. Okay, so one arms of the manometer is exposed to the atmospheres, so will be here. Okay, where else another arms is connected to the gas supply, so will be here. So that means the air, the part labeled A is exposure to the atmospheres, so will be added by the atmospheric pressure. Okay, while at the part C, okay, the the parts, okay, the arms is actually added by the gas pressure. Okay, so here you can see the pressure C and pressure B will be the same because both the water level will be at the same level lah. Okay, so we can conclude that the gas pressure here will be equal to the pressure at B. Okay, so gas pressure will be equal to atmospheric pressure, which is added at the point A, and then we have the pressure liquid at B. Okay, so we adding both pressure, we get this formula. Okay, atmospheric pressure plus liquid pressure, and the liquid pressure we actually learned at section 2.1 already, which will be equal to rho GH. So the rho will be the density of the liquid we apply. So you like say using a mercury, the density for the substitution here we're using the density of the mercury. Okay, G will be the gravitational acceleration, which is 9.81, and then the difference level of liquid will be H here. Okay, so this will be the different level of liquid. Okay, so at your school, actually, you will be conducting one experiment, okay, to determine the gas pressure using the manometer or water. So we're using the water in the school experiment, okay, because the mercury will be a dangerous liquid, which will be cause poisons to the user. Okay, so at school we're using the color water. Okay, you can use the plain water and then you add on the color to the water lah. Okay, so the appressor setup as shown in the diagram will be the manometer. Okay, so slowly push the syringe piston up to the reading of the 8 ml on the syringe so that the water level inside the two U-tube arms become uneven. So the uneven means that initially they will be at same level. When you push the piston to the to reach the 8 ml, so that means you apply the gas pressure, okay, to the manometer already, and cause the arms level of liquid will be different. Okay, and then repeat the step 1 and 2 on the syringe reading to 6 and 4. So that means we push the piston more inward lah. Okay, become 6 ml and then 4 ml. So we expected the different level of H, okay, as mentioned just now, will be higher, okay, which indicate that the gas pressure is increased, okay, when the volume decreases. Okay, so record your result in the table. Okay, so the table will be probably like this. Okay, so this is manipulated reading 8 ml, 6 ml, and 4 ml. So that means the volume of the syringe will be decreases. Okay, and then as we're using the water as our liquid in the manometer, so that means that the air pressure here is actually the atmospheric pressure, which will be equivalent to the 10-meter water. Okay, so 10-meter water will be the unit for the manometer here as we apply the water as our liquid here. Okay, I think this is already discussed by the Jekung Hasista last week, okay, at section 2.2. Okay, so the first reading here, as mentioned, we will be actually measure. Okay, we will be measure the value of H here. Okay, will be measure H here. So this is just a reference number for your answer. Okay, so as per just now, the volume decreaser will cause the pressure increase. And then the value of H will be increased also. Okay, if let's say we get the value, first value with 10 cm, so we expected when the string push more inward to 6 ml, okay, so the pressure will be increased. So the pressure increase, that means that the H will be increased also. Okay, and then for the 4 ml, we expected will be also increased. If your trend or your reading H is increases, so that means your experiment reading will be correct. Okay, and then we measure the gas pressure by this formula as per a discussion for the previous slide. Okay, so the PATM will be the atmospheric pressure. Here will be 10 meter water, and the liquid pressure we need to change to meter. So 10 cm will be will become 0.01 cm. Okay, and then we get 10.001 meter water. For the second value will be 10.002, and the last will be 10.003. Okay, so this is the experiment you will be do at your school. Okay, okay, so we have already finished our first learning standard, and now we go to our learning standard 2, which is solve problem involving gas pressure in daily life. Okay. Okay, so there are 3 possible methods to read the pressure of gas by using the manometer when the tap is open. So you can look at the table here. So for the first method, you can see the water level. Actually, the liquid level here we're using a mercury. So the mercury level at 2 amps, okay, is same level. Okay, both is same level. Okay, so that means that the gas pressure will be equal to the atmospheric pressure. Okay. So the second, okay, here when we're using the liquid by mercury, that means the atmospheric pressure will be 76 cm mercury. So for method 2, you can see this arm, okay, so the liquid level is higher, okay, which is exposure to the atmospheric pressure. So that means that the gas pressure at here, okay, will be higher than the atmospheric pressure. So that means the gas pressure will be atmospheric pressure plus H. Okay, so the H will be here. So will be HCm mercury lah. And then for the third, you can see the arms which exposure to the atmospheric pressure is lower than the arms which is adding by the gas pressure. So that means here the gas pressure will be lower than the atmospheric pressure. So the gas pressure will be atmospheric pressure minus H lah. Okay, so this will be the 3 possible condition, okay, you will be see at your question. Okay, so now let us discuss the question 2. Okay, so let us read the question together. A mercury manometer with one end attached to gas supply. So will be here lah. Is shown in the diagram below. So the density of the mercury is 13,600 kg per meter cube. Okay, so the atmospheric pressure is 76. This is given by the question, and the G is equal to 9.81. Okay, so the question asks you to calculate, okay, so the gas pressure in unit of cmHg and Pascal. Okay, so the first, we need to get the value H, the different level, liquid level here, okay, which is equal to 12 minus 5. So we get H will be 7. Okay, so here we're using the formula atmospheric pressure plus H, because the gas pressure level will be higher, it will be lower compared to here atmospheric pressure. Okay, so we plus, we get 83 cmHg. Okay, so from unit of cmHg, we convert to pasca, okay, we need to using the formula rho Hg, which we already learned at the section 2.1. Okay, so we have to convert the 83 cm to SI unit, which is equivalent to 0.83 meter. Okay, so we substitute rho, which is the 13,600. This is the density of the mercury, and H will be the 0.83, and G given as 9.81. We substitute to the formula and we get the value will be 1.107 times 10 power 5 Pascal. So your answer must be at least 2 decimal places and with correct answer, correct unit. Okay, and then we go to our question number 3. Okay, so here diagram shows a water manometer used to determine the gas pressure. Okay, here you can see the liquid used will be water. Okay, so we need to give our unit in cm water lah. And the question asks you to calculate also the gas pressure in Pascal. So the atmospheric pressure in unit cm water is equivalent to 1000. Okay, equivalent to 1000. Okay, so density of water is 1000 kg per meter cube and G given as 9.81. Okay, so for the first A, we calculate cm per water units. Okay, so here also showing that the gas pressure is greater than atmospheric pressure. So we're using, okay, P gas equal to P atmospheric pressure plus P liquid. So H will be here. So we're using 25 minus 5 to get our H. Okay, so we come 20. Okay, so atmospheric pressure will already given by question, which is 1000 plus 20. We get answer will be 1020 cm water. Okay, for the gas pressure in unit cm water. And then B will be same as the previous question. We have to using the liquid pressure formula. Okay, firstly, you have to convert cm into unit SI, which is meter, and it will be 1.02. Okay, and then we substitute to the formula rho Hg, rho will be 1000, density of water, and H will be equivalent to 1.020, and G will be 9.81. Substitute to the formula, and then you will get your answer will be 100,062 Pascal. Okay. Okay, and then for the next question, question 4. So this is one of the example question from the SPM 2019. Okay, so this is a question. So diagram 12 shows a balloon is connected to manometer to measure its pressure. So here you can see also the gas pressure, okay, will be also higher compared to the atmospheric pressure adding here. So we're using the formula P gas. H will be here lah. We have to get H here. And we're using the formula P atmospheric plus H. So H will be 8 minus 6. So it will be 2. So 2 plus 36, 76, we get 78. So answer will be D. Okay. Okay, so I think we can have a short break. Cikgu Hasita.
Okeylah, anak-anak pelajar, kita berhenti rehat seketika. Jangan ke mana-mana, kembali lagi seketika nanti.
Berita baik untuk semua. Kini Akademi YouTuber memperkenalkan sistem mata gancaran kredit AYU untuk dikumpul. Jom ikuti kelas tuition live AYU untuk mengumpul kredit AYU dan berpeluang menebus hadiah-hadiah yang menarik. Hadiah bernilai lebih RM10,000 disediakan secara percuma untuk pelajar seluruh Malaysia. Apa tunggu lagi? Tebus ganjaran hebat ini sekarang. Layari www.academyyoutuber.com untuk maklumat lanjut.
Okey, kembali lagi bersama dengan Pusat Tuisyen Percuma Akademi YouTuber untuk subjek fizik SPM petang-petang ini bersama dengan penyampai kita Mr. P. Jadi sebelum cikgu serahkan kembali kepada Mr. P, cikgu nak war-warkan beberapa perkara dulu. Semua kelas AYU ini akan diberikan sijil penyertaan yang akan dikongsikan di hujung siaran nanti. Jadi pelajar-pelajar bolehlah isikan menggunakan email EDD, email Jawi dan juga email MOE ataupun email delima. Selain itu juga anda juga berpeluang untuk menebus mata ganjaran dengan mengisikan kod yang akan cikgu berikan di sepanjang kelas ini nanti. Apakah hadiah yang menarik yang boleh anda tebus? Anda boleh semak pautan-pautan pada katalog yang diberikan di bahagian deskripsi video ini. Dan sekiranya anda belum lagi memuat turun aplikasi Akademi YouTuber di Google Play, di Android anda juga boleh berbuat demikian. Bagaimana cara nak download juga ada dinyatakan di bahagian deskripsi video. Jadi muat turun aplikasi ini sekarang dan anda bolehlah menonton pelbagai video PDPC dan juga video-video yang lain yang diterbitkan oleh Akademi YouTuber untuk manfaat semua. Okey, jadi cikgu berikan dahulu dua kod yang seterusnya iaitu 71. Okey, cikgu ulang sekali lagi dua kod yang seterusnya 71. Okey, kembali bersama Mr. P. Silakan Mr. P.
Okay, so terima kasih Cikgu Hastita. Okay, so let us continue for a few more questions. Okay, so actually subtopic 2.3 is quite easy lah, and quite short. Okay,
Betul.
so we have another about 3 questions here. Okay, so for question 5, okay, so look at the question together. So the diagram shows the manometer containing mercury with a density 1.32 times 10 power 4 kg per meter cube. Okay, so the liquid using for this manometer will be mercury with the density given. Okay, the manometer is connected to the gas supply. So the gas supply will be here. Okay, so calculate the pressure at point B. Okay, point B will be here and then point C. Okay, so from the figure you can see point C and point B, actually they are at same level. So we expected the pressure will be the same for these 2 points. Okay, so the question given another information will be the atmospheric pressure will be equal to the 76 cm mercury. Okay, so at point B will be here. So the point B will be added by atmospheric pressure at A, and then also the pressure caused by the liquid at here. So atmospheric pressure will be here. So here will be pressure liquid lah. So that means we have to add atmospheric pressure with the liquid pressure. So with the unit cm, so that means will be 8 lah, the H. Okay, so 76 plus 8, we get answer will be 84. And then the question asks you to get the answer in also another unit, which is Pascal. So we're using the liquid pressure formula, which is rho Hg. Rho is the density of mercury given by question, 1.32 times 10 power 4. And then the H will be 0.84, where we change the 84 cm to meter. Okay, will be 0.84 lah, which is divide 100. And then the G will be 9.81. Okay, so we get our value. Our answer will be 108,700 73.28 Pascal. Okay. Okay, and then the question asks about the pressure at point C. Okay, point C, that means that will be here. This point will be have the same gas pressure with B. So here you can see pressure at point C is equal to pressure at point B because they are at the same level. So that means the gas pressure will be also 84 cm mercury, and the value for Pascal will be also the same, which is the 108,773.28 Pascal. Okay, so for the same question, but for B, what is the pressure of the gas supply? So the gas supply will be at point C. So that means the gas supply will be have the same value as the pressure at C. So that means the answer will be the same. Pressure of gas supply will be equal to pressure at point C. Will be here. So will be equal to 84 cmHg and also 108,773.28 Pascal, which we get from A lah. Okay, and then for the last C, if the manometer is made from the smaller diameter tube, what will be the effect on the height of the mercury? Column AB. So here, explain your answer. Okay, so here, is it when we using the smaller tube, smaller diameter tube? Maybe like this now. So the level of AB will be changed or not? So actually will be not lah, because according to the liquid pressure, okay, the formula will be rho Hg. So that means that the density of liquid will be affected the H lah, okay. So the H here actually will be the same no, because we expected the diameter is not affected the gas pressure, okay, because the shape, the surface area, all is not affected the liquid pressure. So that means the height will be the same. Okay, so the height of the mercury column does not change. Okay, because the pressure is in the independence on the size of the manometer. Okay. Okay, so we go to our last question actually. Okay, so question 6. This will be the example question for section B of paper 2. Okay, so will be the 20 mark question. So diagram 4.1 shows the manometer before connected to gas supply. So will be here. So you can see the water level will be the same. So that means they both will be added by the atmospheric pressure. So for diagram 4.2, okay, this shows the manometer after connected to gas supply. Okay, you can see the arms for both will be different. Okay, so the different level for these two arms will be measured by this value lah, H lah. Okay, so the first question, what means by pressure? So pressure, the formula will be F over A. So that means the answer, you can just convert the formula to sentence, which is force per unit area. So you'll get the first mark. Okay, for the second question, based on the diagram above, explain the working principle of a manometer to measure gas pressure. Okay, so for this one, you can see the diagram will be like this. So initially, both level will be same. When the gas supply to the tube manometer, so the level will be changed. Okay, so the first manometer consists of glass U-tube filled with color liquid. So as mentioned, we're using liquid, mercury, or water. Okay, so this will be the first mark. The second, the gas pressure is equal to the pressure at point A. So it will be here. So here will be the gas supply position. Okay, and then the next, the pressure at point A will be same at point B, so it will be here. So that means both A and B will have the same gas pressure. And then for point B, the point B will be added by the atmospheric pressure and also the liquid pressure here. Okay. So the formula for the gas pressure will be H plus atmospheric pressure. Okay, so we go to our B1. So diagram 4.3 show a mercury manometer connected to compressed gas flux over here lah. This point. Okay, there are 3 value given, which is the atmospheric pressure equal to 76 cmHg. Density of liquid is 13,600, and the gravitational acceleration will be 9.81. So what is the pressure of compressed gas in cmHg? Okay, so that means we just need to get the value of H lah. Okay, so the gas pressure here will be equal to this point. So that means will be atmospheric pressure plus liquid pressure. So the liquid pressure will be measure the value of H lah in cmHg unit. So the first atmospheric pressure given is 76. It will be this. And then the mcmHg will be indicated by diagram, shown by diagram 4.3, which is 30. So you add on, you'll get 106 cmHg. So the substitution, you get first mark. Then second mark will be the answer with correct unit. Okay, and then the second question asks you to calculate the pressure in unit of Pascal. So again, Pascal, you need to change the gas pressure in cmHg to Pascal with formula rho Hg. Okay, so the rho will be density of mercury. The value is given here, and the H will be the value at A1. But you have to change the cm unit to meter. Become 1.06 times G, you get final value will be this. Okay, Pascal. 1.414 times 10 power 5 Pascal. So again, your answer must be at least 2 decimal places and correct unit. Okay, and then the third question here. Why are mercury manometer rarely used nowadays? So normally we're using others safety liquid lah, example water. Okay, so why? Here the question 1 mark. So that means the answer you can give 1 point lah. So mercury is toxic liquid and harmful, or you can mention easily burn. Okay. Okay, so we go to the last question, 10 marks question. So we advise candidate do in table for this type of question. So diagram 4.4 shows for design of gas thermometer PQRS with different specification. Okay, it will be here. So when the glass bulb containing constant volume gas is placed in the liquid, so that means here you will place this part to the here is at the hot liquid lah. So you place at hot liquid. So that means when put in the hot liquid, we expected temperature increase. Okay. So why? Because the pressure increase when the temperature increase. So that means the air in the glass tube will be expand. Okay, and then the reading will be showing or indicate by the value of H lah. So when the H value increases, that means the liquid temperature is higher. Okay, so this is the concept by thermometer, which can be also used to measure the temperature of the liquid. Okay, so you can see the gas in the bulb will expand and show reading as the liquid in the tube rise. So that means measure the value H, okay, which is also measure the temperature for the gas. Okay, so study the specification of the 4 thermometer. Okay, explain the suitability of each aspect, and then determine the most suitable design of the thermometer, which measure the high temperature liquid based on the following aspect. Okay, so here you have to discuss the diameter of the glass tube. So will be here lah, okay, and then the type of liquid used, thickness of the wall of the glass tube, type of the tube used. Okay, so as per just now explanation, the temperature increases will cause the gas pressure increase because the gas particles collection to wall or container increase lah. So that means we expected the H will be increased. So the H increase, that means the temperature is increased for the concept of the thermometer here. Okay, so the first you have to discuss the diameter of the glass tube. Okay, so when the glass tube smaller, so the sensitivity will be higher. So you can see the higher expansion shown by the H value. Okay, when using the smaller diameter of the glass tube. So that means we need to choose a small because of the gas easily expand. And then the second, the question asks about the type of the liquid. So here we have 2 options, which is mercury and alcohol. And here we prefer mercury because the mercury able to expand uniformly or can see clearly. Okay, and then for the third will be the thickness of the wall. Okay, of the wall of the glass tube. So we need to have thinner wall of the glass tube. Again, this is because of the sensitivity of the heat. So that means the value H will be showing higher lah, okay, with the small change of the temperature and the liquid if you're using the thinner wall of the glass tube, because the heat transfer will be more easily. Okay, and then the last will be the type of the tube used. Here is also have 2 options, which is the rubber tube and the stainless steel tube. So we choose rubber tube because the rubber tube is more flexible and is a good heat insulator. So that means the heat in the manometer here will be not transferred out to surrounding. Okay, while for the stainless steel tube, the heat conduction is better. So that means the heat will be transferred to surrounding easily lah. Okay, so then the measurement will be not accurate. So we'll choose P for the question. So as per mentioned just now, you are advised to do your answer in table. So the first, diameter of glass tube must be small. Okay, gas easily expand or liquid increases rapidly. Second, liquid use will be mercury. here we have two options for you. Able to expand uniformly, can be seen easily. And the third one is a discussion regarding the glass back wall, which we require thinner wall, okay? So absorb heat easily, more sensitive to heat, okay? And the last, we choose the rubber tube because it is good heat insulator and flexible, easy to bend. So the thermometer we choose will be P, and then we copy all aspects here. The first will be using the small diameter of glass tube, mercury liquid is used, and then thinner glass back wall, and we choose the rubber tube for your last landmark here. Okay. Okay, so this is the discussion for subtopic today's 2.3. So I pass back the stage to Cikgu Hasita. Okay, Cikgu Hasita.
Okay, terima kasih banyak Mr. Pei. Thank you very much for the very clear explanation. So pelajar-pelajar, tajuk ini satu tajuk yang pendek saja dan mudah. Ada dua standard pembelajaran saja yang harus anda kuasai. Yang pertama, kalau boleh cikgu buat sedikit kesimpulan bagaimana hendak mengukur tekanan gas menggunakan manometer. Yang kedua, bagaimana kita selesaikan masalah yang melibatkan tekanan gas. Okey, jadi ada 6 contoh yang dibawakan oleh Mr. Pei tadi. Sekali lagi cikgu nak ingatkan, pelajar-pelajar bolehlah muat turun semua link PDF latihan yang cikgu Pei berikan pada hari ini pada link yang diberikan di bahagian live chat tadi. Dan anda juga bolehlah cetak keluar sekiranya ada mesin cetak di rumah. Okay, jadi jangan lupa bersama kami lagi pada siri-siri yang akan datang. Minggu hadapan kita akan sambung dengan tingkatan 5 iaitu Cikgu Teacher Linda dengan tajuknya 2.7 iaitu daya impuls. Okay, manakala untuk tingkatan 5 tingkatan 4 bersama dengan Teacher Linda iaitu 2.7 pada Jumaat 9.30 malam, dan untuk kelas tingkatan 5 yang seterusnya insya-Allah akan cikgu sambung semula iaitu tajuk 2.4 iaitu prinsip Pascal. Okey, jadi sebelum tu cikgu nak beri peluang kepada rakan cikgu dahulu iaitu Cikgu Yani untuk sedikit ucapan dan pesanan mungkin. Buka mic Cikgu Yani.
Selamat petang. Walaupun kita tak begitu ramai pada hari ini, tapi cikgu sangat berbesar hatilah atas kehadiran beberapa orang. Tak ramai pun tak mengapa, tapi kita boleh belajar dan terus belajar. Good luck untuk next exam. Okay.
Okey, terima kasih Cikgu Yani. Dan seterusnya Mr. Pei, mungkin sedikit kata-kata terakhir untuk petang ni.
Okay, so saya harap para pelajar boleh mengambil cuti ini, okay, bukan saja bercuti lah. So boleh juga arrangekan masa bila boleh belajar, okay, sebab rasa sekarang mereka mungkin akan menghadapi ujian satu kan, okay, dan seterusnya ujian pertengahan tahun. Okay, so semua work hard and work smart.
Okey, terima kasih Mr. Pei. Okey, cikgu kongsikan dua kod yang terakhir dahulu iaitu 06. Sekali lagi dua kod yang terakhir 06. Jadi link sijil, link rekod kredit telah pun Cikgu Yani kongsikan pada ruangan chat. Anda bolehlah klik pada link-link tersebut untuk claim sijil kelas kita dan juga rekodkan mata kredit menggunakan kod-kod yang cikgu sebutkan tadi dan juga username presenter kita iaitu t.me/pkh. Jadi terima kasih banyak-banyak diucapkan kepada semua yang bersama dengan kita daripada awal hinggalah ke akhir siaran ini. Mudah-mudahan perkongsian pada petang ini memberi manfaat kepada semua yang menonton. Anda boleh juga tonton semula kelas ini pada link yang sama bila-bila masa saja anda free. Okay, jadi manfaatkan masa dan ruang yang ada. Selain daripada kita bercuti, ulang kajilah untuk peperiksaan yang akan datang, dan cikgu ucapkan selamat maju jaya kepada semua sehingga kita berjumpa lagi dalam kelas-kelas yang akan datang. Assalamualaikum, selamat petang dan bye-bye semua.
Bye-bye.
Wow, banyaknya hadiah menarik menanti anda.
Wah, kini Akademi YouTuber mengambil inisiatif baru di mana memberikan hadiah-hadiah ini secara percuma. Ya, percuma kepada anda semua. Bagaimana caranya? Dengan mengikuti kelas tuition online percuma Akademi YouTuber sambil mengutip mata kredit, anda dapat menukarkannya dengan hadiah-hadiah yang menarik ini. Tunggu apa lagi? Segalanya percuma.
Jangan lepaskan peluang tau. Dah dapat banyak hadiah menarik, takkan nak lepaskan peluang.
Layari www.academyyoutuber.com sekarang untuk maklumat lanjut.
Dibawakan kepada anda oleh Akademi YouTuber.